And my intent here is not to try and answer every question, but rather give you an idea of what you really have to focus when you're studying. So anatomical parts, those pictures that you saw in the lecture, in the PowerPoint, you're going to see them in the exam. I think I published the 6-page worksheet. Did I not? Oh crap! I promise. Like walk me to my office after the class because it's ready. I thought I uploaded on the Blackboard. It's there. It's not really big. It includes both respiratory and lymphatic anatomy, so you can just identify there. All pictures that are in that worksheet, you will see those pictures on the exam. Nothing more. Okay. So in terms of the parts, so let me kind of like quickly go over, realistically speaking, all different parts of the nose. Yes. All different parts of the nasal cavity, tonsils, Palatine. You saw the study guide. Realistically speaking, in relation to the lungs, I'm going like all the way down there. So yeah, you do have to identify trachea, primary and secondary bronchi, well, lobar bronchi basically, but that's it in terms of the bronchi. In terms of the lungs, lobes, fissures, left, right. Yeah, the fissures that separate lobes. Okay. Sorry. Yeah, probably the hardest part is trachea with all the cartilages. Just memorize those cartilages. Good. You know, glottis, vestibular folds, vocal folds. Know them. I will ask something out there. I will ask something about the larynx. I will ask something about parts of the pharynx, but it's like taking candy from a baby. All of it is pretty straightforward. Okay? Know which ones go into the respiratory, which ones go in the conducting. So we start with the terminal bronchial and all the way down terminal respiratory, alveolar sac. That's respiratory zone. Everything before that, conducting. You good? Steps. Okay? Now, I want you to be like very, very clear about this. If I ask you, something happens during external respiration, and you have statements, even if one statement makes sense for another process, forget it. Do I make sense? So if I tell you that during external respiration, concentration, pressure of CO2 in the tissues is higher than in the blood, in external respiration it's not. There's no tissue involved. Do that make sense? Am I being clear? I want to avoid any confusion about this. So technically, statement by itself is correct, but it doesn't refer to external respiration. If you see internal respiration, then alveoli are not there. You good? Clear? Awesome. Features of the nose, functions of the nose. Well, we do not make sounds with the nose. We do temperature exchange. We moisten the air. We sense the smell. We trap the stuff. Okay? May I not touch extensively on anatomy, if you don't mind, because it's really, you can memorize it in like a day. I believe in you. Okay. So roof of nasal cavity, ethmoid, sphenoid, floor of the nasal cavity, palatine, maxillary, epithelium. Yeah, I will ask about epithelium, questions that you saw something in that general route. Clear? So know your epithelium. Basically, you can think of it this way. All the way to oropharynx, pseudostratified ciliated. Oral, laryngeal, top of the larynx, stratified squamous. You go on the trachea, again, pseudostratified ciliated. Okay? Functions of cilia, blah, blah, blah. Main components of nasal secretion. What I want you to understand. Mucus, lysozyme, immunoglobulin A. That's practically it. Nasal conchae and meatai. Surface important of prenasal sinuses. Resonating chambers for speech. Perinasal sinuses. You have to be able to identify. Can you name it for me? Like right off the bat. These two are frontal, maxillary, and I'm not going to stick my fingers all the way in the cranium, ethmoid and sphenoid. Okay. Rhinitis, inflammation of sinuses and nasal cavity, main parts of the pharynx 3. Are we clear about main parts? We good? Nasolaryngeo, type of epithelium, pseudostratified ciliated, stratified squamous. Only nasopharynx is involved in the respiration. Larynx. Where does larynx start? Larynx start with where laryngopharynx ends. Okay. It opens into trachea, functions. Voice and separation of food and air. We good? Moving on. Superior portion stratified squamous, inferior pseudostratified ciliated. When I ask why, don't tell me, it's God intended purpose. What I mean is upper part of larynx can be in contact with food. So stratified squamous. Lower part of larynx, only air. So pseudostratified ciliated. Clear? Cartilage that forms Adam's apple. So thyroid cartilage, function of epiglottis. Closing the respiratory passages when we swallow. Elastic cartilage comprising. Now, vocal vestibular folds. All you need to know is that vocal folds, they produce sound, vestibular folds don't. Okay? How do we make sound? We'll push the air vibrates. Vocal folds, they produce sound. Sound depends on the tension and the size. Okay? Which never explained to me the voice of Mike Tyson. Now, loudness, that's a different story. That's the, not amount, but speed at which air leaves the lungs. Makes sense. How these things affect sound. In, like, one word, resonate. They resonate. Does that make sense? Like echo. Clear? Do vocal folds produce speech? They do not. Tongue, lips. There's actually it's like an ethnicity back in Russia. They actually have special technique of singing with the throat. So they produce modulation, like they don't sing with the mouth, they sing with the throat. They produce sort of words with the throat, which is pretty cool. Valsalva's maneuver, closing glottis, closing glottis by vocal folds, preventing air from leaving the lungs, stabilizing the trunk. Okay, pretty straightforward. You can see a lot of questions that are in their own way outright stupid. Which parts of respiratory system are connected by trachea? What I want you to know is the order. You have to be comfortable with telling me nasal cavity, nasopharynx, oropharynx, laryngopharynx, larynx, trachea, bronchi, blah, 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 terminal bronchioles, respiratory bronchioles, alveolar duct. Am I clear? Just step by step the passage of air. Okay. Layers of tracheal wall, they can be on the exam. I mean anatomy. Pointing at the layer, which layer it is. Okay. Epithelium, pseudostratified ciliated, function of trachealis, contraction of trachea and expulsion of mucus. Trachea branch into. Again, I promise anatomically we will not go beyond lobar bronchi. That's as far as we can go. Clear? Good. Orders, you have to understand, every smaller segment of the lung is supplied by the next order of bronchi. Bronchioles, know that respiratory zone starts with the terminal bronchiole. I'm not going to ask you which order of bronchi finishes the conducting zone. Structural changes, that's what I asked you today about. Cartilage is basically replaced by the elastic connective tissue. Now you have to understand when I say replaced, just, amount of cartilage goes down. Therefore, percentage of elastic connective tissue goes up. Sort of a balance. And amount of smooth muscle increases. Epithelium switches from pseudostratified ciliated to basically simple cuboidal in the end. Amount of smooth muscle. What's the function of smooth muscle in bronchioles? To constrict and regulate airflow. Structures of respiratory zone. Be able to identify on the picture terminal and respiratory bronchioles, alveolar duct, alveolar sac, and individual alveoli. In alveoli, there is an external respiration, gas exchange. Respiratory membrane. What forms it? Endothelial cell. Basically, the membrane of endothelial cell in the pulmonary capillary, basement membrane, and the membrane of the type 1 alveolar cell. Let me draw it for you just to remind you. So this is endothelial cell. This is basement membrane. And this is type 1 alveolar cell. Essentially, this is the respiratory membrane. Make sense? Why it should be thin? To facilitate faster gas exchange. Please know that type 1 alveolar cells are simple squamous. Type 2 alveolar cells are cuboidal, use surfactant. Function of alveolar pores is to equalize the pressure in different alveoli. Alveolar macrophages clean up whatever gets in the lungs, right? And then what happens to macrophages when they die? With the mucus, they get expelled up towards the larynx where we swallow them. Clear? Stroma of the lungs, mainly elastic connective tissue. Now, when I say what is, that's anatomy. Costal surface, the surface that faces ribs. What enters at the hilum? Pulmonary veins, pulmonary pulmonary arteries, bronchi, everything basically enters at the hilum. Right lung is bigger, has 3 lobes. Left lung has only 2. Fissures, know them. Segments are the functional units that can be removed surgically independently. Okay? Just know that feature. That it's basically the smallest part of the lung that can be independently removed. Pulmonary and bronchial circulation. Know the difference between them. Understand that pulmonary is all about gas exchange and getting oxygen from alveoli to the systemic, to other visceral organs, while the bronchial circulation is about supplying oxygen and nutrients to the lung tissue, right? Where do bronchial veins drain the blood? Pulmonary veins. And it actually makes perfect sense, because you don't need to create an additional path to drain to drain them in the superior vena cava. Think about the stroma of the lung. It's a connective tissue. There's not a lot metabolic activity going on there. So they do not produce a lot CO2. So there's practically no dilution of that oxygen-rich blood. Does that make sense so far? Pleura, identify them in the picture. Know what they like. Okay? Space between the pleural cavity filled with fluid. Remember the graph. Like the one slide with the graph. Change in the... Let me see if I can pop it up. Yeah, sure should be able to. I'm talking about this one. So you should be pretty comfortable about this graph. Okay? And that's it. So you should be able to tell me what happens when we inspire. Like, what is the relationship between intrapulmonary atmospheric pressure when we inspire? What is the relationship between when we expire? How intrapleural pressure changes. Okay? Now you have to understand, intrapleural pressure is right here. Intrapleural pressure is right here. The lower it is, the more lungs are inflated. The higher it is, the more they collapse. Correct? So basically this whole story is about the pressure relationships. Okay? So when we inspire, intrapulmonary pressure is lower than atmospheric. When we expire, intrapulmonary pressure is higher. You have to remember that intrapleural should be always lower than intrapulmonary. What happens if they equal? Huh? Lung collapses. Why? 2 things that make lung collapse physiologically. Why it becomes smaller? Because it's elastic. Stroma is elastic. What else? What is in the alveoli? We know surfactant, yeah, but what is... It doesn't take away all the surface tension, right? There is some surface tension. So that surface tension will add on top of the elasticity, collapsing the lung even more. That makes sense? That's it. So when we talk about respiratory pressure, so negative respiratory pressure is lower than atmospheric, positive is higher. Does that make sense? So basically, during expiration, we have positive respiratory pressure. During inspiration, we have negative respiratory pressure. Are we clear? Intrapleural. What makes intrapleural pressure what maintains low intrapleural pressure? Chest wall expansion. Chest wall expansion. And another thing, think about this. It's like a chamber with two big walls. Your chest and the lung. Okay? Chest expands because of muscles. Lung, on the other hand, always tries to collapse. Does that make sense? So basically, these walls, they try to go away from each other. And when this happens, volume increases, the pressure decreases. That's why pressure, intrapleural pressure, is always negative to intrapulmonary. Okay. If fluid accumulates in the pleural cavity, it's going to happen to the lung. Collapse because pressure goes up. Transpulmonary pressure. When the lung goes up, when it increases, turns out transpulmonary pressure, when lung inflates, transpulmonary pressure becomes higher. Okay? Because intrapulmonary pressure is at its lowest during this process. Okay? And then when we expire, transpulmonary pressure becomes small. So it's essentially, if you think about it, it's a change in transpulmonary pressure that allows lungs to expand and recoil. Atelectasis, what can cause it? There are two ways, two major things that we talked about. So, air in the pleural cavity. Now, can you explain me the mechanism, how it works? Yes. Well, go ahead. Think through. So that's what we'll stop at this so far. So intrapleural pressure is equal to atmospheric. What is the pressure in the lung? What is the pressure in the lung? What's the number? How does the pressure inside of the lung relate to atmospheric? It's never more. Well, it can be more at the expiration, but say at resting state, the pressure in the lung, intrapulmonary pressure, how does it relate to atmospheric? It's the same. So if pressure inside of the lung is atmospheric, pressure in the pleural cavity is atmospheric, what's going to happen to the lung? It's going to collapse. Why? Let's say it again. Because lung is what? Elastic, and there is surface. Does that make sense? And there is surface tension. Does that make sense here? Okay. What else? So there are two ways basically. If you think about lung, you can collapse it by two approaches. One, increase intrapleural pressure, and two, decrease intrapulmonary. See it? Well, you can't. What I'm saying, yes, you can. If you increase surface tension, absolutely, absolutely. Like in babies, that's what we discussed. Yeah, sure. I don't know if it's going to cause the collapse of the entire lung. Okay, but probably if they stop producing surfactant at all, yeah, it's going to collapse eventually. Okay, but so in terms of the pressure relationships, how can you reduce intrapulmonary pressure very quickly? Stop air from getting into the lungs. Does that make sense? Air will get basically absorbed. Oxygen will diffuse into the blood. Pressure in the alveoli will decrease dramatically, and lung will collapse. That makes sense. There are two ways. Okay? We got it or not? I don't see you being really sure. No? Just be honest. Huh? Okay. Okay, think about it. Again, I have a balloon. It's really easy to show with a balloon. There's a balloon in my hands. Imaginary balloon. I need to collapse it. Two options. Option number one, I collapse it. Like I squeeze it. So that refers to the higher pressure on the outside. That refers to the higher intrapleural pressure. It refers to what you were saying, hole in the chest wall. That makes sense? Or I can reduce the pressure inside of that balloon. How? I can just suck the air out of it, and it will collapse. Does that make sense? So if we block, that's a bronchus, okay? If we block the bronchus right here, there's no air getting in, but gas inside of the lung is actively diffusing into the blood. So gases leave the lung, going into the blood. Pressure in the lung decreases. Basically, your blood, your pulmonary circulation does this. Sucks the gas out of the alveoli. Pressure drops, lung collapses. Does that make sense? So, treatment of atelectasis, chest tube. Suck the air out. Now, let's just go through this step by step. We will cover like these two parts. Let's do this, and we will say bye-bye to it till Wednesday. So, I inspire. What happens to the volume of my thoracic cavity? It increases. What happens to the pressure in the pleural cavity? Pleural cavity. Pleural. Volume goes up. Pressure in the pleural cavity goes down, right? Okay, let me just draw it for a second. Huh? Do you mind if I'll draw the circular lung and circular thorax? It's just so much easier. Red is the chest wall. Black is the lung. Okay? I expand thoracic cavity. Lung expands as well. Now, what about the volume here? Which volume is bigger, V1 or V2? V2. So if volume of pleural cavity increases, pressure in it decreases. It's already negative, but it becomes even more negative. It decreases. Are we good? Lung expands because pressure here drops. Okay, so P2 is less than P1. So lung expands. What happens to intrapulmonary pressure? It decreases first, and then at this moment, like yes, when there is no airflow, it's equal to atmospheric. Now, at this moment, transpulmonary pressure, the difference between intrapulmonary and intrapleural is what? That difference is greatest. It's greatest. Does that make sense? And then I start to expire. This moment, intrapleural pressure goes up, intrapulmonary goes up, volumes decrease, but pressures go up, and what we care about is that intrapulmonary at expiration is higher than atmospheric. At the end, very, very end of expiration, like at this moment, what is the ratio between atmospheric and intrapulmonary? It's equal. That makes sense? You just have to understand, when there's no airflow, pressures are equal. If you have two vessels and there is no flow between them, pressures in those vessels are the same. Period. Does that make sense? So we practically covered these two things. And we're going to start with this discussion on Wednesday, and we'll finish the review on Wednesday. And we will review the quiz, of course.